Hello pre-calculus students, and welcome to the lesson on a video on solving trigonometric equations, particularly this equation. And one of the things that you want to try and do when you solve an equation is think about what makes this equation hard. Okay, so think to yourself, what is it that makes this equation hard? Because if you can think about why it's difficult, it'll help you to work at making it easier. Okay, so for example, what makes this difficult is there is both cosine and sine involved in here, and it's challenging to solve this because we can solve an equation with one trig identity. It's much harder to solve if you have two trig identities, and they're two trig ratios, I should say, and they're mixed in there. Okay, so one of the things we're going to try and do is separate sine x and cosine x. Okay, and we're gonna try and just think about this for me for a minute here. Let's try to solve a simpler problem. What if you had this equation, 2ab minus a is equal to 0? Could you solve this equation? Well, you have two variables. You have a and b here. So, and you only have one equation, so you would think that this can't be solved. But one of the nice things about this equation is this 0 here. Having 0 actually makes things a lot simpler to work with. So let's just look at this simpler problem here. Well, we're going to factor out an a. So now I have 2b minus 1 equals 0. And then we're going to use the zero product property, which is often used but rarely identified, and it's kind of an unsung property, but it makes things a lot simpler. So now I can say that a equals 0 and 2b minus 1 equals 0. So one of the things I want you to take away here before we even solve this problem is when you're faced with something difficult, try and solve a simpler problem. Try to look a simpler but similar problem. Okay, so this is a non-trig problem, but it's very similar to this. And so hopefully you see now that the technique here is we want to separate sine from cosine by factoring out a cosine. So I'm going to factor out a cosine of x, and what I'm going to be left with inside of the parentheses here is just 2 sine x minus 1, okay, equals 0. And let's see if the factoring was done correctly. The way we check is if you were to redistribute this, cosine times 2 sine, that's what you would get. Cosine times -1, that's what you would get. So we're good. And then again, apply the zero product property here. And we can separate this into two separate equations. I have cosine of x equals 0, and 2 sine of x minus 1 equals 0. And then I'm just going to solve each of these equations now. Well, look at the unit circle. Where is cosine equal to 0? It's up here, and it's down here. So that means x equals pi over 2, and x equals 3 pi over 2. And of course, I have to add 2 pi n to this in order to get all solutions. On this side, on this other equation, I'm going to say 2 sine of x is equal to positive 1. Sine of x is equal to 1/2. And now I have to solve for x. So we'll look at the unit circle again. And you can just picture it visually. Sine is the vertical distance, so it's about right here, where it's 1/2. And on this side, well, this angle here is pi over 6, or 30 degrees for those of you who still like degrees. And then 5 pi over 6, or 150 degrees. So then my answer are x equals pi over 6 plus 2 pi n, and x equals 5 pi over 6 plus 2 pi n. All together. So there's infinitely many solutions, but they take 4 different forms. Pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, pi over 2 plus 2 pi n, and 3 pi over 2 plus 2 pi n. So just kind of look back through this problem and see kind of the strategies that we use, which is to separate sine and cosine, looking at a simpler problem, and then applying it to this particular problem. Okay, and again, these are strategies. What makes this difficult is they don't always work every single time. You have to think ahead, you have to think for yourself, and you have to do a lot of these problems in order to get some good experience at this. As always, ask your teacher if you need help with this. Okay? We are now going to try and solve a slightly more difficult problem, and let's see if we can apply the same concepts to that one. Okay, so now I have another problem here. 4 cosine squared of x minus 4 cosine squared of x plus 1 equals 0. And think, what is it that makes this problem difficult? Well, hopefully you see that you have different powers of cosine. Okay. And this is something we have not dealt with before. So again, let's think about, when have you seen different powers of a variable before? Well, let's see if we can solve this problem. What if I give you 4y squared plus 4y, whoops, not plus 4y, minus 4y plus 1 equals 0. I mean, could you solve this problem right here? Well, of course you should be able to. This is a quadratic. You can use the quadratic formula. You can try to factor. A is 4, B is negative 4, C is 1, and you can certainly use the quadratic formula. Okay. And we're going to basically apply the same concept here, and we're going to make a substitution. And we're going to say that y equals cosine of x. And it is perfectly okay to create a new variable. It is perfectly okay to make a substitution to make this problem a little bit simpler, as long as you convert it back. So we're going to make this note here on the side and just make sure that we convert it back. So this now becomes 4y squared minus 4y plus 1 equals 0. You can solve this problem your favorite way. I'm going to solve this by factoring because I'm pretty sure this can be done. This is going to be 2y minus 1 times 2y minus 1 equals 0. So one thing that I can do here is say this is 2y minus 1 quantity squared equals 0. Okay. And then I can solve this take the square root of both sides. 2y minus 1 equals 0. 2y equals 1. Y equals 1/2. Okay. So that worked out very nicely for us. But remember, because we made this substitution before, we have to change it back. Okay, we have to make this unsubstituted. I'm just going to say change it back. Okay? So again, nothing wrong with making a substitution as long as you change it back. So remember that we're solving for x here, we're not solving for y, so I'll change it back. Cosine of x equals 1/2. Well, where on the unit circle does cosine of x equals 1/2? Well, it's up here and it's down here. Now it's not on the left side because cosine is the horizontal distance. If it was on the left side, it would be negative. Okay, so at this point here, this is x equals pi over 3, or 60 degrees for those of you who are still stuck on degrees. That's 2 pi n. And then down here, this is 2 pi minus 1/3 of a pi, so that's 5 pi over 3 plus 2 pi n. Okay. And once again, when we're done solving a problem, we want to take a look back at this and see if this makes any sense. Well, let's see, and what the strategies are so we can apply this to the future. Well, the main idea here is this represents a quadratic, but instead of a quadratic with one variable, it's a quadratic of a trig ratio. So we'll just make the substitution. We turn it into a quadratic problem that we know how to solve it, make the substitution back, and now we solve the trig problem. Okay, so basically, we take away the trig part of it in the beginning, solve that, put the trig part back in when we're done, solve the trig problem. And here you have There are, again, infinitely many solutions, but they are basically two forms. One of them is going to have pi over 3 in them. The other is going to have 5 pi over 3 in them. Okay. So again, I've left a couple problems here on your notes to try it on your own. You absolutely got to do it. Make sure you really work on it as much as you can on your own so that you get some good practice at doing this. That's the only way we get good at these types of problems. They are challenging, but you are certainly capable of them. If you have any questions or any problems, as always, remember to ask your teacher. Thank you for watching, and have a wonderful evening.